Hello and welcome back to another episode of Shenzhen I, where once again it feels like I've taken a very long break and I have no idea where we left off. Or what did we do last episode? Oh, the target illuminator, is that it? Okay, I do remember that. Interesting. Do you want to optimize that more? No, I think we were happy, right? We couldn't get the power down more, which bothered me a little, but other than that, I think we were fine. And I think we read out of this. Yeah, we did. Alright. Can you keep a secret? Haunted door project. Hey, so I was doing some research on the internet. It seems that if a door is a haunted door, it brings way more interest. Haunted doors are... I don't know why that is weird to say, but it's weird to say. To get caught on a live stream are almost guaranteed to go viral. So what if we took some of the doors from a factory around here and put some parts in them to haunt them, then distributed them along with the normal doors to toy stores? Oh my god, haunted door. I don't know, I can't say that right. It doesn't. Haunted isn't hard, and door in and of itself is not. It doesn't sound quite right when I say it though. Door. I don't know. Let's leave it. I just have to keep it a secret so it doesn't leak that we're manufacturing them here. Joe, are you serious right now? Lily. This is brilliant, I love this. I found some appropriate sound effects online. I think Sinister Giggle and Blood-Curdling Cry are the best for of that bunch. Now you just need a random number generator, preferably a haunted random number generator. We have some unmarked chips from a long time ago in storage. The original purpose or maker is unknown. Seems interesting. I put some in the prototyping bin also. Perhaps this part was created by a ghost shift. That is just some joke. Humor. Gee. Perfect, Jay. Let's go terrify some live streamers. Why live streamers? Are they actually... I mean, we are in the near future. Maybe there's like a thing that's called live streaming, where you stream your entire life instead of live streaming as in live as in happening right now. Live? I don't know. Who knows? Also, I don't have this open because I don't know what I'm doing anymore, as I already told you. New design. Haunted door. Random is a simple input connected to a random number generator. What is random though? Is this random? Oh, sure. Speaker is a simple output connected to a miniature self-amplified audio speaker. When a value of 1 is randomly generated, play the Sinister Giggle sound effect. When a value of 2 is randomly generated, play the Blood-Curdling Cry sound effect. Look in the supplemental data section of the manual for the audio data that Carl found. Blah, 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 blah. Sure. So let's find the... what do I look for? There we go. Welcome to Dark Lord 555's creepy sound effects page. This page was designed for Internet Explorer 3.0 or better. You're the 1792nd. Oh, well, it doesn't say second, it says tooth. The 1792th visitor to this page. You have found yourself in a dark wood, in a huge forest with no beginning or end. What is that noise? Before you know it, darkness has taken you. These sound effects were recorded and modified by me, Dark Lord 555. They are free to use. You can use these sound effects to scare your little sister or whatever else, I don't care. Alright, and then it's just a sequence of numbers, I guess, that I need to send to this. Yeah, for the Sinister Giggle, it's 180, 41, 14, 14, 41, 69, 74, 54, 27, 19, 40, and 75. Right, so this is 100, then 80, 41, 14 twice, then 41, 69. So we definitely need some of the storage things for this, I would assume. We need to play 2 different sound effects, Sinister Giggle and Blood-Curdling Cry. How many numbers? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13? Is that it? 2, 4, 6, 8, 10, 12. Yeah, 13 different numbers per screen or per audio, I guess. I think, oh no, maybe they're not the same. 2, 4, 6, 8, 10. No, it's also 13. Some of the other ones, they're more sound effects on that list, but you only need those two, and they're both 13 different numbers, I guess, frequencies. I don't know. It's not frequencies. I don't know what this is. I also don't know what this is. It's a haunted chip. I guess this is the input though. What we do know, what is very good, is that both are 13 long, so we don't need to worry about that. I don't remember how these work though, because we never really used them. We've just looked at them. You don't need to save anything into them. Which one is the one I can edit here? This one, so we want this one, I guess. So we want to start with 100, then 80, 41, 14, 14. Wait, is there maybe a happenstance? No. I was just wondering if there was a repetition there on the other one too. Because then we could have just ignored that, I guess. 41, 69. Where were we? 180, 41, 14, 14, 41, 69, 74, 54, 27, 19, 40, and 75. And then I guess we need another one for the other one. Oh, maybe let's just work with that for now, because I don't know how this works. It's a simple input, which I guess is nice. How much code will I need for this? It feels like not a lot. This is kind of inconvenient. We want this to go here and this to go here. And then I guess something like... But we need two of them. We definitely don't have enough pins like this, so we definitely need a big board. And I guess we just use A1 and D1. Well, not quite like this, but like this. And then we need the second one down here, and we use A0 and D0 for that one. Also not quite like that. And then we just go to the speaker here. That already feels like excellent. I don't know. So we want to check if the input is 1 or 2, and if it's something else, then we don't care. It's generating 1 through 100, obviously, because it's a simple input. All right. So we want to test if... What's the best way to do all of this? If P0 is... I mean, we could just do a lower than... and then test again, I guess. Just to have like a general ignore everything. If it's this, with one test, that might be worth it to have. Is it lower than 3? If no, then jump to the end or something. I'm not sure if we want to jump or not. It's hard to say. If it is lower than 3, I also need to look up how these work. What are they called again? 200p14. Read-only memory, yeah. So which one is which one? One of them is like the index and the other one is the where we get the value. Memory pointers can be read or expressed with the A1 or A0 address pins. So A is where we read the pointer. Memory values referenced by pointers can be read over X-bus with the D0 and D1 data pins. So I want to send so if it's lower than 3, then I want to also know if it's 1 or 2, I guess. Not sure if this is actually a good way to do things here. I'm also not sure if we'll have enough code. We'll definitely have to loop for like 13 reads and always like increase. What's the best way? What's the best way? Because we want to move. That's not move. It's move. We move Act to X1, I guess. And then we read X0 to P1, and we add 1. Oh, and there's a default output. That was never in the specifications. I hate that. I really hate that. It's never in the information. It's just in the verification. Oh, when there's nothing, just output 50. Why would you output 50? Like, that doesn't make any sense. But okay, whatever. We'll do that. Sure. I hate you. I hate this game sometimes. So if it's not, we move 50 to P1. Stupid thing. Why did I not read the... Like, I know it's not looping yet, so it doesn't really work, but I thought it would do the first value at least. Like, here's 1. Which is lower than 3, so it doesn't jump to the end, and it moves AC, which is 0 here. And it gets X0 back, which is 100. So it's 100 here. Oh, but then I guess it does this, and yeah, that screws everything up. Right, because it doesn't sleep. Makes sense. Loop is not a good name for a label here, but you know, it is what it is. And it's gonna, like, this is gonna do the right thing until it's almost over, and it's just gonna always. Oh, that is interesting behavior, though. That's actually what I want to look at this, because I never reset AC. So AC is 13, which is the no, 14 is the last one. So it goes to 14 or whatever. And it gets a 0 right here. Wait, no, what? 1? Oh, no, it's not. 13 is the last one. It's 14 values, but 0 is the first one, of course. So 14 is 100 again. So I guess if the index is too high, it just loops around. So it doesn't just not return anything. Yeah, it just keeps going through the list as this increases. That's good to know. It's not really useful here, I think, but it's good to know that that's what's happening. All right. And now we just need Maybe I want to actually save it. Can I do it in one loop is the big question that I have right now. I definitely think we can make this a working solution, but I'm not sure if I can do it in one chip, and I'm not sure if I can do it in one loop. I have to have 2 loops. How many lines do I have left? Like this loop is a lot of lines. 1, 2, 3, 4, 5, 6, and doesn't have a break condition yet, so it needs another line. And I only have 1, 2, 3, 4 lines left, which is not a lot. Because I also want to, like, if ec is 12, jump somewhere. Yeah, this is not gonna work out. It's almost very nice, but it's just not. I guess let's put in this second thing. 16, 36, 42, 14, 10, 58, 100, 76, 26, 28, 70, 80, 42. Okay, so I have that at least. So if it's 12, we're on the 13th value, so we're done. I wanna leave the loop. So it would be like this basically, but this is not gonna work because I'm not resetting ec. Also something is not working at all because there's no conditional here. Stupid. And also it's also always triggering this one instead of sometimes this one. Can I change that? I mean, I could test every time in the loop, but that feels like very bad power management. Like I could have a test if it's 1, and if it's 1, like plus here and here, and if it's minus, have the other 2. But for that I would also have to save that, right? Which already is bad power management too, but maybe we can get it on one chip. I don't think we can though. Yeah, it doesn't feel like it's possible because now here I would have to test. I can't reset the values is the thing. Maybe, actually not sure. Also no, I don't have enough space here. Because if it is 1, we want to send ec to here and do this, and if it's not 1, we want to do this and then need another line. Because now I can't break. Ah, what a shame. I'm wondering if there's a way to make this more compact. Because I mean, basically the idea would be this would be the other option then. But now we're not sleeping. Also for some reason, wait, I never ended up in the loop? Oh, because there's no... How does it actually get out of the loop? I'm confused. But yeah, I have no way to reset Eck, and I don't have a way to break the loop. I mean, this would do both outputs, but... And I wouldn't have to reset that at least, because that's get automatically reset once I'm out of the loop. I'll just have to break the loop. If it wasn't for the stupid default output, I think I could do it. But the 50 default output is just like, it's just stupid. I hate it. And I can't do it with a clever test here, right? Because I will do greater than 1. I can't do that because everything's greater than 1. Like getting rid of this test right here, just jumping into the loop right away. But still having this as a thing that compare doesn't work, because compare, if it's lower than it does something, if it's greater than it does something, but if it's equal, it ignores all the conditional statements. So I can't really, like if I test compare 2, if it's lower than 2, so if it's 1, I can trigger something, and if it's greater, then I can jump out, but I can't make the rest of the thing work. Right, because the test compare statements yeah, it disables both the pluses and the minuses if it's equal. So if I test compare 2, it's going to do nothing. And I could have, if it's less than, then it does the minus. So if it's less than 2, do this. So these two would have to be minus. And if it's greater than, I could have a plus instruction that jumps to the end. But I can't have the second output within the loop then, can I? Unless I have another test in there. But I don't think that's gonna save me any lines, is it? I guess I would give up take away 2 lines here. And if I do test compare, if it's 2, and if it's greater than 2, then jump to the end. And if it's lower than 2, then do this. What if I do this? I'm not sure if this is gonna work. It's a weird way of doing things, maybe. But now all I need is a break. Oh, but I still can't reset ACK then, can I? Ah, that's really unfortunate. Because the break to break the loop is it takes 2 lines. Because I'd have to, yeah. And now I think this does everything except reset ACK. And then that messes things up, obviously. Also, why does it actually break before it's supposed to here? Let's just look at that. Oh, because this is 12 and we're doing it after the add, right? So we have to test 13 actually to get this part right at least, but now what happens here actually? Let's see this. Input is 2, so it sends, I guess, a 0 back, which is obviously wrong. 36. It's just off by 1 now? Yeah, I think so, right? Because... why? Also, why does it not stop now? Oh, because it's never, obviously, 13 again, so it stays in the loop, right? I'm stupid. So the only thing I'm missing here is reset ACK to 0 after I jump to the end. Or if it's 13. Ah, if I could just do it. I hate it. And I need to save P0 into a variable here, because otherwise I can't keep checking it in the loop, which I'm doing now. I would have to check outside the loop somehow, which I don't think is going to be possible. Ah man, this is disappointing. So close. Once again, so close. Yet so far. Is another way to do it? I don't think so. And the thing is, like, this would be pretty elegant. It's not super elegant actually, because it does a lot of unnecessary stuff. But it would be just a nice little solution, I guess. Ah man, that's so disappointing. Yeah, I guess we have to break it up into 2. What a sad day again. I hate when that happens. So close, but I can't make the really good solution work. It's not about, yeah, it's not even about finding a solution, it's just making it nice, I guess, is what I'm not getting done. So I guess we'll just use one of these. I don't know if this is enough actually. Let's just hope it is. Oh, but this doesn't have an output now. Ah, so I can't use that because I need to go to the speaker. See, everything gets more complicated and stupid if you have to add more pieces to it. It's just a nuisance. But now I can't connect to this from here because this doesn't have enough pins. Ah, come on. What if? Yeah, what if? Let's do something drastic here. If you take a bridge from this, A is the index, right? Move X to X3. Move X to X1, yeah. So if we take this one, but somehow I've managed to turn my audio all the way down, which is not a big deal. I get caught in the chair, the control thing with the volume thing. All right. So what if we do this? See, that feels very smart. Does it not? Why is it off still? I guess it's sending in inputs to X2, which, do I care about that? I've not really thought about this. I guess it doesn't care, even though this is a non-blocking input-output thing. I'm not sure why this is not a problem. I guess it isn't, so I'm just gonna be okay with it for now. Okay, well, so what happens here now? Our input is 2. That's compared to, we don't jump to the end. We move X to X1, which is 0. And then we move X2 to P1, which is 16. Yeah, that seems right. And we sleep. But why did it send us 0? What? Why did that, what did that do? Sleep for 1. It's not 13, so we do it again. It is 2. We move this down to the 36 one. Send the 36 over. Is this late by 1? Is that what's going on? Up, up, down, down. But then it breaks right. Why is this up? Why is this wrong? Like, where do I get I get the 0 from here, I guess, but why? Does it matter if this is D0 and A1? Does this make a difference? I don't think it will, right? Oh, it does. Okay, fair enough. Why is this wrong? 16 should have been 0. No, it should have been 16, but it was a 0, and then it was right. Like, why does that happen now? I don't understand that at all. Because this is the same as the first one. Why does it work? The first one gets a 1, and nothing, then a 2, then a 1, then a 2. Why is it wrong for the first one? That is very strange, is it not? So the first one works now. First test. And then the second test works. I mean, we're wasting power by unnecessarily cycling through the second memory. But we're always cycling through both memories now. Because of the bridge that we built. But it feels like that should work. And it doesn't. So why does it not work? We get a 2. Our read is on 16? Why is this not that way around, but this way around? Not sure, it's 2, so we send the 0 over. But I don't get the value from here, why? I'm confused by this. Maybe we can't make it work then. I don't know. I don't know what's going on. I don't really know what the problem is right now. What is this piece called again? The 200p something? 14? Independent auto-incrementing memory pointers. The auto-increment? I've not really noticed that, I guess. But that makes this whole thing easier, doesn't it? Because I only need to reset the pointers once. I see, that makes everything much easier. Because I don't need to count it R. I don't need this. Oh, I still needed to break the thing, right? But I don't need to send this at R. I just need to do this. Yeah, the auto increment. So whenever you read a value, the pointer increments by 1 automatically. That's a very good solution. We beat Chrome in R categories, which is the most important thing. That is really good. I really like this. I didn't read that. See, I should read the manual more. It says auto-incrementing memory pointers. Which means now we only have to set it to 0 every time before we loop to read the first value. And we're wasting a bit of power, definitely, by doing it like this, but I don't think I have enough space. Yeah, we have no space, so I don't think I can really make a whole lot of other things work here. But that's very good. Nonetheless, so I'm happy. So many emails. Haha, it worked. Kind of. Someone posted their haunted door. I can't say that right. Being haunted, and was starting to gain some attention, but very soon afterwards they opened up the door and found the mechanism, so the mystery was solved pretty quickly. But I still don't know where it came from, and I believe that Ghost electronics have a potentially very bright future in the marketplace. You could even build them during ghost shifts at our assembly lines. I will continue to research the possibilities. Stop right now. I forbid you from doing anything further relating to ghost electronics. Lily Wu. Okay. She's very assertive, Lily, I have to say. And Cho is a bit of an odd guy, I guess. It's an interesting combination. How long is this episode? It's not very long. It's not very long, so we have time for a hand of solitaire. Where we are at 25 now because of a live stream that happened a few days ago, a couple days ago, a while ago. I don't even know how long ago that happened. It feels like an eternity. Alright, so we have green, 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 green. Not great. Red, 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 red. Not terrible, but covered by black twice, so getting black out of the way first might be the better move. So I guess we work towards that goal. We only have 2 here, so that's going well, I guess. Now we have 3 here, so if you just do this, we can do that. And now for red, we have 1, 2, and then 3, 4 right here. We just need to open up this slot or something somewhere. Don't have a lot of space to do that though. I would really like to get in here. I'm not sure if I can. Actually, yeah, this is not as easy. It looked like it would open up a lot, but it didn't, because the number distribution on the cards here is just not good. Because you can't move that 6, and if you move it up, you can't move the 4. If I move this up, I can move nothing, because I can move the 7. I can't move the 9, I can't move the 3. Yeah, we could move the 8 onto this 9 here, but it would just make it harder to get to the red. We would maybe open up 2 slots though. If you move a green, feels like a risky move. But I think it's gonna work out. So, no reason to worry, I guess. That's what I'm trying to convey here. Oh, this is annoying. An annoying combination of colors here. We can do this, and we can do move the 9, move the 6. Just need to get in here, really. But I can't move that 4. Well, I can if I really want to. Yeah, okay, fair enough. And what's still blocked out this? Didn't even see that. There we go, 26 wins. 74 more to go. But we'll worry about that in the future. This was a very successful episode, I have to say. I'm happy with that solution. Very happy. And then, yeah, a bunch more to go. And a bunch of other emails here. I still don't know. I still would like I mean, I guess it makes sense not to be there, but I would like to know how many more levers or tasks there are before the campaign is over, the main campaign thing. But I don't know. I could look it up, but I don't. I don't know. I don't wanna. I wanna know, but I don't wanna look it up. But I feel like we are definitely like more than halfway through, right? I think it's at 30 at some point. 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm not sure if this one counts, so we'll ignore it. 10, 11, 12, 13, 14, 15, 16, 17. And that would be 18, 19, 20, 21, 22, or maybe 23 if this one counts, which I don't know if it does. We also might have to come back to this. I just don't know what I would design in terms of a game. We could just... yeah, but we're not gonna do that now. Not yet, at least. So that's it for today. I hope you enjoyed, and I'll see you with more coding adventures. We'll code something. We don't know. A little help. Hard to say what that's going to be. I assume it's going to be... oh, wait, is that actually the next one? Yeah. No. That's one we've already done. Down here. Custom specifications. Also not very telling, so we don't know what that is going to be either. But yeah, that's it for today. I hope you enjoyed. I'll see you next time. Bye-bye.